Okay. Thank you, Scott. Good morning, everybody. My name is Parminder Bogri. I'm a state technical manager with the state of California, Office of System Integration. I'm also a cloud migration lead.
Good morning, everyone. My name is Vishal Prabhu. I'm a managing director at Deloitte. I serve the state of California and I'm the West Coast lead for cloud services.
Okay, so we are very excited to talk to you about how we took this huge and massively complex health exchange system to the cloud and how we did it with almost no defect at go live. So here's what we will cover today. We'll give you a brief overview of our effort and our mission, and what were our goals, how we approached the migration, and information on our solution, and the impact this technology has on millions of people who call California a home. Well, we call it CalHERS. It's a long acronym. It stands for California Healthcare Eligibility and Enrollment Retention System. It's one of the largest of its kind in a country. The system helps people research, compare plan, check their eligibility, and eventually buy healthcare from the system. One out of like every 4 California depends on this system to buy affordable healthcare or get health insurance through the state's medical program. We're talking about 7.7 million total user accounts. There are 8 Exadata and Exalogic servers. We have 6 petabytes of archive data, 134 external partner connections. We have 540 servers, and we have 2 data centers like primary and this campus. And we use over 1,200 open source technologies. We have 46 environments. So CalHERS required like collaboration with many players. But the migration itself was done by the Cover California, Department of Healthcare Services, Office of System Integration, Deloitte, and AWS. Next one, please. So how do you take one of the largest of its kind in the country and then provide a platform which can support millions of consumers shop for their healthcare coverage? And do it, especially during the national health crisis. So first of all, it's more than an infrastructure, architecture, or data or application challenge. So what do we start with? Right-sizing the infrastructure with AWS, like a network, compute, storage. That saves you millions of dollars. And then that saving can then be used to serve better and provide better, more services to the California taxpayers. And finally, we wanted to put ourselves in a position where we can easily adopt innovations and the updates and the new technologies coming down to us from the AWS. With the cloud, now CalHERS can drive innovations from numerous angles. So what we wanted was a future-ready system. We also needed flexibility, so we can dynamically scale environments up and down to meet the business needs. Because this is very important for the healthcare system, where we experience dramatic peaks and valleys through the open enrollment periods. We also want to deliver a consistent consumer experience throughout the year and save us a lot of money through this process.
The CalHERS contract with the Deloitte began in August 2019. Working with the state, we defined a lift, shift, and innovate strategy to cloud modernization. What you see here on the slide is a 5-step cloud migration effort that Deloitte executed with the state to move the CalHERS system into the cloud. We kicked this off with a discovery and planning phase. As part of this, we did a bottom-up discovery of the assets that comprise the CalHERS technology portfolio. We did an inventory of the servers and the network assets We did an inventory of the software, the licenses, and the versions. We did a mapping of application to database, and system utilization metrics. And you'll see in our later slides how this information was crucial in right-sizing the infrastructure for the cloud and to deliver a highly performant system. The outcome of this exercise was a target state architecture and a refined cloud migration plan. Working with our AWS team, we did an assessment of this architecture against AWS's well-architected framework. And we applied the lessons learned, the recommendations from that assessment into the target state. By doing this really early in the process, we are able to improve the cost to quality. We also use this time to build the trust and transparency in our communications between Deloitte as a system integrator, the California IT teams, the sponsors, the stakeholders, the partner agencies, and external collaborators such as our previous vendor. In the next phase, we did the build and migration of the environments. We leveraged Deloitte's cloud migration factory. You can think of it as an assembly line which standardizes the way we move assets into the cloud. And our alliance with AWS to build out the foundational architecture in the cloud. We built out the environments. We built out the security ecosystem for this infrastructure. We built out the network architecture and migrated the interface connections. And we moved hundreds of terabytes of data using AWS Snowball and built out the databases in the cloud using AWS's Database Freedom program. While we were doing these activities, in parallel, we started the validation and cutover planning activities. So as part of a validation, we did really rigorous functional, performance, and infrastructure operations validation activities. Given the scale and complexity of this cloud migration exercise, we saw the need to do early cutover planning and soft launch activities. So we did a number of mock cutovers and over 6 soft launches. So this included security, the security ecosystem, the databases, data warehouses, interfaces, and our infrastructure operational readiness activities. By doing this, we are able to significantly reduce the stress going into the cutover. The results of our validation, we shared that as part of our go, no-go meeting. And we did this about 10 days in advance of the actual cutover to solidify the support from the key sponsors and stakeholders going into the cutover. We've also got approval from the Center for Medicaid Services for the cutover, along with authority to connect and operate the system with their systems. In the next phase, which is the final phase, we did the cutover of the systems. This was followed by hypercare. And after a successful cutover hypercare, we then started the decommission of the on-premise data centers. Throughout this exercise, we continue to innovate. We continue to evolve our tools and the thinking so that innovation was not an add-on. It was inherent to what we delivered and how we delivered it. And now, we are in a very exciting phase of our cloud modernization journey, as part of which we are moving the system from its monolith legacy architecture to an open source, containerized, lightweight, cloud-native modern architecture.
So leading up to the migration, our team at the state of California established a handful of clear objectives for the journey of the cloud. Naturally, the first objectives of those was migrate everything to the cloud, AWS cloud. And we migrated the size of a supercomputer with 5,000 cores of highly proprietary Oracle Exadata and Exalogy servers. On top of this, our database migration contained 450 terabytes of data. This is the 6 times the size of the Library of Congress, the digital archives. So what we did, we used AWS Snowball device to copy all the data from our infrastructure to the AWS cloud infrastructure. This required, and then, so we also needed actually 134 different external connections that needed to be migrated along with this cloud migration. That required immense planning and coordination between the network, and the security, and all the collaboration between different vendors. So we used the OCM technologies into that to have the communication go out early in the phase. So, well, we'll touch more on the connections in the later slides. But the security of the whole system, we wanted to have the security for the whole exchange data because we contain all the PI, PHI data. So we were very focused on the security. So the next topic that we're going to cover is on the security of the system.
So Carriers manages a large amount of personal identifiable information and protected health information. A key objective of our cloud migration was to secure this user data very effectively using AWS controls. Carriers prioritizes the security of this data when exchanging it with partner agencies. So this includes state and federal partners, it includes third-party systems. For example, the IRS, the California Franchise Tax Board, the California Employment Development Department, the California Statewide Automated Welfare System, we also know it as CAMSOS. The system also meets federal security and privacy controls by being compliant with MARCI standards. And to attain the highest levels of security, we augmented the AWS security tools with third-party tools to implement features such as single sign-on and multi-factor authentication, network endpoint security solutions, application and network security vulnerability assessments and remediations. And we applied all these changes to deliver a highly secure system in the cloud.
So in migration to the cloud, so we also wanted to design a highly scalable and available system so that we can meet the future system needs. And we knew that we needed this even before the pandemic started. And especially when we have the healthcare system, which have the dramatic peaks, valleys in the whole period. Like the lower peaks usually during a few months in a year. And those few months are absolutely critical for us. So what we did actually, we implemented 3 availability zone architecture with the disaster recovery strategy, just in case there is any disruption in the data center. So what we did actually, we deployed our application into the 3 availability zones. And we used the load balancer on top of that to separate the traffic and spread across all 3 zones for the high availability and the scalability. And we used the custom scripts to build like auto scaling from the standby servers. So what we did actually, we had like the Lambda functions, which the cluster will use. Whenever the cluster needs to scale out, it will use the Lambda function to start one of the EC2 instance, which is already registered in the cluster, and will start. Doing that, what we have is, now whenever the cluster needs, it will just auto scale by itself. With that, what we have, actually what we built is, we have the system which can self-heal and auto scale throughout the year whenever it needs it, without any intervention. Next slide.
Along with high availability and scalability, we wanted to make sure that a system that is available to the entire state of California is also highly performant. The legacy application had been built on highly engineered, massive ExaLogic and Exadata systems, and for which equivalent Oracle systems do not exist in the AWS cloud. So going in, the team was very deliberate in introducing performance tactics in every phase of the cloud migration exercise. So this included discovery and planning, design, and implementation. During our discovery and planning phase, we looked at the system utilization metrics against peak open enrollment conditions. We looked at EDDM, AWR reports to look at what is the maximum utilization of the database IOPS during these periods of peak usage. Similarly, we looked at workload characteristics to understand how much compute that they consume. During the design phase, we refactored this single massive on-premise database node into 3 database servers, and we distributed the workloads across those 3 nodes. We took these massive data files and distributed them across multiple EBS volumes, and we optimized the IOPS on these volumes. Based on the characteristics of the workloads, we deployed them on memory-intensive, CPU-intensive, or storage-intensive compute or instances in the AWS cloud. Our performance testing team did numerous rounds of iterative performance testing and tuning. So this included doing portal performance tests against open enrollment volumes. We simulated endurance tests, stress tests, network utilization tests. We simulated availability scenarios, high availability scenarios, failover scenarios, login surges. We even tested our interfaces with partner connections such as the Employment Development Department and with the Center for Medicaid Services. We tested our batch jobs, over 500 batch jobs of daily, weekly, monthly with peak open enrollment volumes. We tested out our data warehouse, massive ETLs against peak and passive renewal volumes. The team applied over 100 tunings across the compute, the network, and in the middleware codes to deliver a system which is faster in the cloud as compared to on-premise. So now let's talk about external partners. Carrier's success depends on its ability to closely collaborate with 43 partner agencies. These include the state and federal partners, the insurance carriers, and third-party systems such as our print vendor. We included our stakeholders in every phase of our cloud migration journey, starting with the earliest discovery and planning activities. We coordinated our testing plans, be it connectivity tests, functional testing, performance testing, with each of our partner agencies. Additionally, our change management team met regularly with the key stakeholders to keep them to socialize the progress of our cloud migration through every phase of this journey. Given the size and complexity, and if you remember what Parminder shared earlier, we are talking about 134 interface connections across 43 partner agencies. The size and the complexity of this interface migration is very high. To reduce the stress, to reduce the risk, and to reduce the outage window during this cutover, we work with every partner agency to route their production traffic in phases through the AWS cloud infrastructure. And we did this several weeks in advance of the actual cutover. And this significantly reduced the outage window required for the cutover and resulted in a seamless, very successful cutover.
Okay. So we realized very early that work-based dynamics and the change management were really successful to the adoption of the cloud. So we applied Deloitte's human capital and the change practice so that our people could take this cloud journey together effectively. So the change management was the core focus of this cloud migration as well. And our vision for the OCM was to make sure everyone who touched our system had the clear understanding and the confidence in the cloud migration. And our vision for the OCM was make sure that there's no surprises for anybody across the team or across our stakeholders and the sponsors. This meant that we clearly communicated the progress and the performance of the whole technical solution at all different phases. And what we provided the Cal heroes with the ecosystem, the visibility into the migration. So what did we achieve? Well, as I mentioned earlier, we started this journey even before the pandemic. But during the COVID special enrollment, carriers reported 4 times the average monthly enrollment rates that we had. When that happened, we truly realized and appreciated how important it was that we have the future-ready system. With this cloud migration, we got the higher availability, speed of delivery, agility, and the flexibility to meet the business demands in a cost-effective way. We got this cost saving by eliminating the data center overhead and the operational cost and the maintenance by right-sizing the infrastructure with the AWS. But most important, we establish a modern platform that can accelerate adoption of the emerging technologies and simplifies the continuous innovation. We recognize and appreciate the success of this project helps the state better serve families all across California. With that, we're very eager and excited to share our lessons learned and our experience with other technologies who might be facing the similar project. With that, we are ready to take your questions. Thank you.
Please go ahead.
So you said that there's a lot of cost saving here, but you are still having these two instances, right? So the maintenance is not still cost prices and whatever. So if it is a big data center with data is terabytes, so what is the other solution you have in mind apart from this? Is there any other alternate solutions?
Sure.
Okay.
I can summarize it.
Okay.
So please let me know if I summarized your question correctly. So the first question was from a cost efficiency standpoint. Given that we are going to a system in the cloud and we are using EC2 instances there, what are the cost efficiencies that we got from that exercise? And the second part to that question was instead of Oracle on EC2, are there any other options, right, which could further help reduce the
Right.
cost?
So Oracle is, EC2 is Oracle licensed, right?
Sorry, what is that?
This Oracle licensing option is still there with the EC2.
Correct. That's right.
So it's a kind of balanced out with an effort, and is it a cost saving option?
Got it.
Okay. So I'll start with
Sure.
that. So what we did actually, the first thing that we avoided, so when the Calvius project, when we started this cloud journey, so we had the hardware which was already aged out, right? It was end of its life. So we avoided that several $1 million project to replace the whole hardware in our data center by going to the cloud. So the first thing that we wanted to do is do the lift and shift. Just migrate everything to the cloud, right? At least that we get rid of the hardware replacement cost. The second phase was, actually the Oracle cost. So we already had the licensing that we took, like bring your own license. So we did not change anything, that we had the good contract. The next phase actually that what we are working on is modernizing our infrastructure, where we are going towards more open source technologies, cloud native, and the microservices, where we can scale our system based on the system need and all those small individual components instead of scaling up the entire infrastructure. So those are the few things that we are working on it for the next few years. Vishal, please add something.
This is great, Praveen, that you covered all the points. We went with the left shift and innovate strategy, so I think we covered everything.
Which means hardware is already out of.
Oh yes. Yeah, we decommissioned the hardware. It's gone.
Yeah.
Right? So that reduces the hardware refresh cost as well. Yeah, please go ahead.
Yeah. Just to add on more, like the way we did it, like after the cloud migration, we waited for like 3 weeks or 4 weeks, and that was our like hypercare, like a period where we monitor, we checked our network traffic, if anything hitting our data center. Once we made sure that everything is good, clean, there's nothing, no dependency, we kind of like decommission our data center completely.
So what do you think that this would be a balancing like benefit cost-wise? How many years it will be there to zero over your over? So did you have any presentation on that with the customer? Saying that these 10 years would be bringing back whatever the efforts and the cost you have put in here, efforts, vis-a-vis new environment, maintenance, and everything. So based on that, do you have any knowledge here?
So this question was, from a return on investment standpoint, what is the rate that will break even? Was that it?
Yes, yeah, when it's break even.
Yeah.
We have the timelines, but I will not go to the exact dollar amounts. But for the state of California, what we had, something in front of us, as I mentioned earlier, the hardware. The entire hardware in the whole 2 data centers, we had primary and the secondary, everything was under support, and we were paying the extended support to our vendors and for the software as well. So what we did with this, we avoided that whole CapEx expenses, and then we were paying the hosting fees to our data center as well. That cost itself for a year was more than what we are paying to the AWS for a whole year, if that makes sense. Avoiding, not discounting the hardware cost and the support cost and the maintenance cost for that. It's just paying the hosting in the data center versus AWS is a lot more cheaper.
Thank you.
What's your question then?
Thank you both for sharing the incredible journey of a very successful data migration to the cloud. I heard a lot of the comment about innovation, so very, very curious if you could share about your vision for future innovation. Specifically, I'm very interested in how do you want to make use of the data now that everything's in the cloud? If you could comment on the data-led transformation, that'd be great. Thank you.
So if I heard the question right, it is now that we have completed the migration to the cloud, from a next step standpoint, what does the further evolution in the cloud journey look like? Yes. So as Parveen had mentioned earlier, we followed a lift and shift approach to cloud migration. Now, the next set of goals that are driven by our business include reducing system complexity, improving performance, and continuing to optimize on the cost for licenses and for the system. So as part of this exercise, we are going to transform the system from this legacy monolith architecture to a lightweight, open source, containerized cloud native architecture. So as part of this, we continue to bring in additional innovations. Even when we did the lift and shift into the cloud, we brought in a number of innovations that impacted and helped the business grow. So these include, the next generation disaster recovery solution that we deployed in the system. So with this, the workloads are being processed actively across the multiple zones in the architecture. We brought in self-healing bots to give the ability to the system to automatically look for and correct from any failure conditions. We brought in innovations such as auto-scale, which allows the system to flex to demands of usage based on the cyclical nature of the business. Parveen, do you want to add anything?
I think you covered all of that. Yes. Okay. Did that answer your question? Thank you.
It's different. It's going to be a different question, but I think the answer might have been very similar. I'm currently advising a similar project, scale as well as complexity. And one of the things that it was a choice between lift and shift with the monolith versus going greenfield with a containerized platform. We chose OpenShift and we were doing the containerized version. And, we have our struggles, but I did hear that you had mentioned both containerized, auto-scaling, and I was curious how you had that fit into the monolith. Was it already in a containerized fashion or something that led to that? Or did you have to evolve the monolith in a way that allowed for AWS's auto-scaling to best utilize that?
Do you want to summarize?
Yeah, sure. So I'll please see if you got the correct question correct. So the question is, we followed a lift shift approach, and now we are going through a transformation journey. But there's another school of thought wherein we could modernize the application on-prem, right? Move it from a containerized, lightweight implementation, and then migrate to the cloud. There's a third school of thought where you could, do this phased application modernization and migration. So what were the experiences with it? Was that your question?
Most of it, but the conclusion was more of when you utilize the Amazon's auto-scaling, at what part of the application did you use that on? In other words, did you use it on the whole monolith, where you just creating replicas, or the parts of the lift and shift monolith application that you were able to apply the auto-shift without compromising its monolithism? I was just curious how you use the auto scaling on the monolith, because it's something a little bit different than the containerized versions of auto scaling right now.
Got it. So let me try to summarize that question. Given that it is a monolith system, how did we apply the auto scale capabilities to that system when we migrated to the cloud?
Yes.
So the first thing, right, like as you were saying, why we chose this approach of doing the lift and shift first instead of modernizing our infrastructure before actually going to the cloud, right? So that we can, like, it's a clean, like, green field out there, right? The thing was, we thought of this at the state of California. The challenge that we were is we had to race against the time, right? We, as I mentioned earlier, our hardware was already aged out, and from our hardware vendor, it was told to us it was the best effort if anything fails. But we have, like that, the open room where it peaks during those 3 months. If any consumer is lost, like that time, it's a big impact to the consumer. We cannot take the risk. So we have to come out of that risk first, like the hardware. So we chose and go to lift and shift. One is to avoid the risk of the hardware failure. The second one was, it was easier from the business side to communicate to them and get their buy-off that we're not changing anything. It's just, instead of running here, it's running on modern platform, which is more like advanced and fast. That's the thing that we decided that we'll go lift and shift. Along the way, as we see the opportunities, we'll do the modernization. We did, right? We kind of like built a hybrid auto scaling into that. So not, even though it's not like lightweight completely yet, but we identified our pain points, which components, which side it's hit more. And those are the things that we did. We did the hybrid manual where we have the instance already kind of installed, but in a stop state. So we are not built from AWS. But with using this AWS Lambda function, the cluster will just automatically start one of that. Whenever it sees, it has the triggering point where it sees the load, it just automatically starts that stop instance in the cluster, so that it can just like auto scale by itself.
That's spectacular. So if there's no other questions, I have others.
Given the size of the migration, I imagine that you had a large amount of supporting engineers and administrators for the applications and systems. How did you all handle training and upskilling of team members given the timeline was so aggressive?
So if I heard the question right, given the timeline for the cloud migration, the lift and shift approach, what did we do from a training standpoint to get our teams ready as part of this exercise?
Yep.
So, let me just elaborate.
Yes.
So from a timeline standpoint, we called out we broke down the cloud migration effort into different phases. We really started very early in the process. We brought in our change management and our operational readiness activities into the entire process. So as the environments were being built out into the cloud and they are being migrated, we are getting our operational team ready with those activities. So it was a combination of training as well as hands-on activity executions. We updated our SOPs, standard operating procedures. We had tabletop exercises as part of that effort, and we executed different types of scenarios to get the operational team readiness. We had KPIs in place which measured our progress against the objectives of getting the operational team ready for the system. Separately, we had our organization change management team, which was keeping stakeholders informed about this change that was coming in. So we were sharing periodic updates with the different stakeholders. This included the 43 partner agencies that we talked about earlier, to inform them of the different changes that are coming into the system so they can prepare at their end for these changes. The third part of this was the different sponsors that we were interacting with. So our organization change management team had this concept of champions, change champions deployed, and as part of that, we had education sessions called out, which informed them about the journey to the cloud. We had cloud migration education sessions 101 through 404, as part of which we went through these different training sessions.
Makes sense. And did you encounter any resistance during that process that you had to overcome?
So the question is, did we encounter resistance during this process? Right? So we had anticipated resistance during this process, but thanks to our change management efforts, wherein we shared, what does cloud involve? How does it impact those end users? I think we were able to build better appreciation of this particular journey. So we clearly called out what our goals were and objectives of that cloud migration effort. And we took our teams, and this is across all teams, not just technology teams, but our sponsors, stakeholders, business users, partner agencies, through the entire exercise. One thing that we learned, one thing that I would carry from this is communication. We communicated, we are very transparent about this plan and the impact that it would have through this process. During this entire journey, we continue to have business changes into the system. So, because the legislative changes such as the ARP, the Biden, those changes, significant changes were coming in as we were going through the cloud migration exercise. So the sponsors, stakeholders could see the impact these changes could have over the cloud migration timeline and vice versa. But by clearly calling out those schedules in advance, along with our remediation steps, we got very good support for this journey. Parminder, if you want to add anything.
No, I think you covered it, but the only thing that I will add on what Vishal is mentioning, the OCM and the cloud champion. So we listen to the business as well, not just giving them information, but listen to their pain point. What they would like to see in the cloud, right? Like especially the performance or faster deployment, or even the internal team where they need the environments to be spinned out, pretty quickly at that. So those things, we actually incorporated their ideas into that and took them along with us into this cloud journey, so that we had their support as well. Thank you.
Thanks for all your insights. We're kind of in the middle of what you're doing, maybe a smaller scale. One of the things I was curious about is you use the Snowball to move most of the data. How did you move the rest of the data? Like, I'm assuming the app was still up, so the people were still using the legacy system. So how did you move the Snowball was for maybe a backup at a point in time. How did you move the rest of the data quickly to AWS so there wasn't a lot of downtime? That's one question. Second question is, you mentioned you moved some of the data files from one server to multiple servers. Do you have any best practices, or because we were thinking of doing something similar? And then my last question is, did you investigate Amazon RDS at all? And why wouldn't you choose that as opposed to installing it on the EC2?
Got it. So if I can summarize those three questions, the first one was, how did you transfer data into the cloud using Snowball, and did you use any other tactics or tools to do that data? The second question was to share additional insights into our process of distributing data files across different EBS volumes. And then the third question was, why did we apply AWS RDS as part of our application? Can I take this question? Yeah, sure. Okay. So we had a huge amount of data to migrate it. 450 terabytes of production data to be migrated, and at the same time we wanted to keep the outage windows to a minimum. We followed a two-phase approach. So really early we understood the complexities of this effort, what it requires. So we tested the migration of data using Snowball. What I would suggest to you is, from a concept standpoint, when you deploy Snowballs into your data centers, there are data center specific considerations that we need to address very early in the process. So we had about 6 cycles of data transfers that we executed, so that became muscle memory for the team, how to migrate data using Snowball to the cloud. The second thing is to reduce surprises going to the cutover weekend. We implemented one-way data set from the on-premise database to the cloud database. So we did a soft launch of the database into the cloud, and till we completed the migration for several months, we had the on-prem data updates being synced into both the online database as well as the data warehouse database. So with this, we checked the currency of the data, we did a data integrity test with our partner agencies as part of this effort, and really minimized the amount of data transfer or migration activity needed during the deployment. Now coming to your second question, this is regarding the approach we took to migrate distribute the data files across EBS volumes. So if not sure how much the team is familiar with the Exadata infrastructure. Exadata is really massive database nodes, highly engineered proprietary Oracle infrastructure, right, which has massive amounts of code, memory, and IOPS. They go to hundreds of thousands of IOPS. When we observed the performance of the database server during different enrollment conditions, we saw a need to optimize on the number of IOPS because we do not have equivalent infrastructure like Exadata in the AWS cloud. So by looking at the IOPS, we looked at the database characteristics and we refactored the databases across 3 databases using in the AWS cloud based on the workloads that were running there. We then looked at the IOPS consumption in the on-premise system for batches, for online transactions, for data warehouses. And then by looking at the data files, the tables that were most frequently accessed in terms of inserts, lookups, the IOPS that were being consumed on it, we distributed it across different EBS storages or volumes. And then we tuned the IOPS on those EBS volumes so that individually those EBS volumes could address table level requirements. So with this fashion, we were able to meet the IOPS requirements with the AWS infrastructure that we had in place. Now coming to the third question, the RDS, why we did not go ahead with RDS. So when we started our journey, the RDS file size, data file limits, the volumes that could be attached to RDS storage that it could process was at 64 terabytes. As we discussed earlier, the sizes of our database far exceed that number. We have 450 terabytes of production data. Our HBX database is over 70-80 terabytes and growing at the rate of 10% year over year. So RDS was not really an option for us. We had to go with Oracle on EC2.
Yeah, like in the first question, I think just to add on that, like as Vishal mentioned, we have the syncing going on from on-prem to the cloud. So we use Oracle's data guard, which just creates as a second standby. Like we had one standby on-prem, the second standby in the cloud, so it's continuously syncing. And like we did few exercises of switching it over, seeing everything's good as data integrity, and that kind of like gave us the surety that data, like on that day, cutover day, is just a matter of switching the roles. That's it. There's no bigger outage required to copy the massive data.
Okay, can I ask you any questions?
Yes, please go ahead.
So since you said only the database portion of it, did you have also app servers? You said that there are a lot of interfaces.
Yes.
And with that, app servers have also been migrated, or is it only the database server? If so, what are any challenges? Because any client which we go, they always have this interfaces, right? With a lot of third-party vendors and the middleware. Some of them are not supported by AWS themselves. So, is there any challenges that you faced with an app server migration, if at all?
Sure. So I'll summarize your question. So the question is, do you migrate the application servers as well as part of a architecture?
Yeah.
And second, were there any interface connectivity or issues or migration issues during the cutover? Right? Kalindasha, can I take this?
Yeah. Like, yeah, please take it.
Thanks. So yes, we had application servers also part of our cutover effort. So we migrated the application servers and their underlying pods into the cloud. The on-premise system was a Exalogic infrastructure. And again, just like Exadata did not have Exalogic infrastructure in the AWS cloud. They use InfiniBands and other technologies for communicating between app servers and between the app server and the database servers. As part of our discovery and planning phase, we got an inventory of the applications that are deployed on the app servers. We also looked at the configurations of the Exalogic infrastructure, and then we built out a corresponding infrastructure in the AWS cloud. Going into interfaces, the partner access gateway, the technologies that we use, the OAG components, that was also a lift and shift into the cloud. The challenges that we ran into was, how do you migrate 134 interface connections over one cutover weekend, right, while minimizing the downtime periods? So for that, we did a very innovative soft launch approach, as part of which we worked with each partner agency to route their production traffic through the AWS cloud infrastructure several weeks in advance of the actual cutover. So imagine, where we are routing the traffic instead of directly coming to the on-premise system, you are happening it in a way through the AWS infrastructure. So with this, it was a great way in which we reduced the risk of the actual migration. We could test out the performance of the interfaces and the endpoints the way they were set up. And we also minimized the number of changes the partner agencies had to do going into the cutover to their endpoints. So this led to a very successful cutover of those interfaces.
Share one more last question. So since you said the app server is being connected directly, is it a production app server connecting to the standby databases or to the production databases? When you tested it, what I meant is when you tested the app server's connection through the AWS cloud network to the new infrastructure.
Sure. So we did our testing as part of our mock cutover testing. We tested out the connections in advance of the actual soft launches of those interfaces. And during the soft launches, this was live production traffic that was being routed from the AWS cloud infrastructure into the on-prem system. And we can go into further details after this session, and we can even share with you the path that we took as part of this implementation.
Appreciate it.
Sure.
Just an alternative approach. What we did is we created a proxy gateway, similar thing where we had it go into the AWS cloud. And we sent it to both systems. We both test out the other system. And now when we did the migration, we just basically flipped the switch again. So it wouldn't go just one. The response would go from, say, the original system, it would come from the new system. So very similar approach. I love that approach. The question I had from earlier was, when you did this migration, did you virtualize the environments before you brought them into the cloud? And we had a little bit of trouble trying to figure out how best to detach from the legacy systems, the non-virtualized environments, and then bring it to the cloud. Just wondering your thoughts on this, and how you guys approach the issue of migration of the monolith.
So if I understood your question right, was our on-premise system virtualized? And the second part to the question was, how did we migrate those virtual systems into the AWS cloud? Is that correct?
Yes, that's it.
Got it. So our
Please go ahead.
Yeah. So yes, our on-prem infrastructure was a virtualized infrastructure hosted on Exalogic. So as part of our migration, we built out the infrastructure into the cloud, again a virtual infrastructure into the cloud. So as part of that build-out activity, it allowed us to correct those failed connections configurations that were in Exalogic and right-size them for the cloud solution. And with that, we built out the entire production infrastructure into the cloud. We did our performance testing, functional testing, infrastructure operational validation activities against this pre-production infrastructure in the cloud. And that improved our ability to migrate as well, of the cutover as well.
Awesome.
Thank you.
Any more questions?
Thank you. Thank you for your great question.
I was going to be on top of shit.
Thank you very much, everyone. If you could share your feedback in the application, we would appreciate it. And in a moment, we'll put up a QR code so you can scan right to it.